Ever wonder why ChatGPT sometimes forgets what you just told it 2 minutes ago, even though it seems like an all-knowing genius? That's because of something called the context protocol. And understanding it is key to using large language models effectively. Today, we're diving deep into the LLM brain to explain the context protocol simply, how it manages memory, and why those context windows have limits. Let's start with the basics. What exactly is a context window? Think of it like an aquarium of fixed, limited space, where the LLM can hold information about your current conversation. Everything the model needs to reference, both your input and its own responses, has to fit inside that aquarium. If the conversation gets too long, the oldest information gets pushed out or forgotten. This is the fundamental limitation we're dealing with in all modern LLMs. The size of this context window is measured in tokens, not words. A token is basically a fragment of a word, maybe a whole word, or even just punctuation. For context, 750 words is roughly 1,000 tokens. While models are constantly getting better and context windows are expanding, we've gone from a few thousand tokens to models now supporting hundreds of thousands. They still are infinite. This is where the context protocol steps in. So, what is the context protocol? Put simply, it's the systematic approach LLMs use to manage the flow of information into, through, and out of that fixed context window. The invisible assistant that decides what information stays relevant and what needs to be archived or discarded to make room for new data. Why is this protocol so crucial? Because if we didn't have it, every single interaction with an LLM would require processing the entire history of the chat from the very first word. That would be computationally intensive, incredibly slow, and astronomically expensive. The context protocol ensures efficiency by only keeping the most immediately relevant data ready for processing. Now, let's look at how the context protocol actually works inside a tool like ChatGPT. It's a blend of immediate processing and sophisticated memory management strategies. The most common method is the rolling context window. As the conversation progresses, new tokens are added to the end. Once the window is full, for every new token that comes in, one token from the very beginning, the oldest part of the conversation, is dropped out. It's literally a first-in, first-out system. This is why if you ask ChatGPT to remember something you said 20 pages ago, it often fails that initial information has been pushed off the end of the context cliff. But modern LLMs often use more advanced techniques than simple rolling contexts. They employ strategies to extend their effective memory without overflowing the literal context window. One key strategy is summarization and compression. Instead of keeping the exact text of every historical interaction, the context protocol periodically generates a summary of the past conversation. This compressed summary is much shorter, allowing it to occupy less space in the context window, essentially condensing dozens of turns into a single, highly relevant summary block. When you start a new prompt, the model reviews the summary block and the most recent few turns to generate its response. Another powerful technique is retrieval-augmented generation, or RAG. This isn't strictly part of the core context window, but it works alongside the protocol to give the illusion of deeper memory. If you connect an LLM to an external database, like providing it with your own documents or previous long-term chats, the context protocol can query that external knowledge base for relevant facts, pull those facts into the current context window temporarily, and then use that retrieved information to answer your specific question. It's like sending an assistant to the library to fetch a relevant book rather than keeping the entire library on the desk at all times. In essence, the context protocol is the gatekeeper and the editor of the LLM's working memory. Manages the trade-off between retaining enough history for coherent log and maintaining the computational efficiency required for rapid response times. Understanding these limits changes how you interact with LLMs. If you need the model to remember a critical piece of information over a long session, you need to deliberately reintroduce it or ask the model to summarize and remember that specific point. You are essentially helping the context protocol prioritize that data. So next time your LLM seems to forget something, you'll know it's not because it's faulty, but because the context protocol is doing its job. Fifthly, managing a finite resource, the context window to keep the conversation flowing quickly. If you found this explanation helpful, give this video a thumbs up and subscribe for more deep dives into the world of AI. Thanks for watching.